Hello. So far in the sessions that we've had, we've been looking at organic chemicals, straight chains of carbon in particular, that are made only of carbon and hydrogen. They are the main parts that sort of form our organic chemicals. Our carbons form the skeleton of our chemicals, and then the hydrogens usually fill in all the gaps. But there are other elements that exist in our organic chemicals, and they usually form the functional groups. The parts of the chemicals that give them their special characteristics, make them react in certain ways, give them certain properties, etc. And so many of our organic functional groups are made from oxygen and nitrogen. There are others. There are some exceptions to this general rule. There are halogens, so things like fluorine, chlorine, bromine, and iodine, that can also form their own functional groups. Usually they just bond on like a hydrogen. And then we also have things like sulfur. Sulfur functional groups aren't included in this course, but they do exist. And then there are other times when metals sort of start to come into the equation as well, but we're not going to be talking about them either. Our main focus are functional groups that have oxygen or nitrogen in them. So to understand how they work, how they form when we're trying to make any of these structures, what we need to do is look at oxygen and nitrogen and start to explore how they bond. So they bond covalently as well. What you'll notice is that I have put 6 electrons around oxygen's outer shell and 5 around nitrogen. So if I flick over to my periodic table, what we should be able to see is that nitrogen is in group 15. They have 5 electrons in their outer shell. And oxygen is in group 16. It has 6 electrons in its outer shell. So I've made that match up, and that's going to be fairly important as we begin to move forward, because that's going to tell us how many bonds we want to be able to form. So looking back previously, we've said that carbon has 4 electrons on its outer shell and that hydrogen has 1. And that tells us how many bonds it's sort of able to form covalently with other atoms. So we've said before that carbon has 4, but it wants 8, so it needs another 4 electrons, so it will form 4 bonds. And that hydrogen has 1 electron and wants an additional 1 to make 2. So it has a full s orbital only, and that it wants to form 1 bond. That way it will get a full outer shell. We're going to use similar kind of logic for oxygen and nitrogen as well. What we want to be doing is adding electrons on through covalent bonds so that we end up with full shells of 8. Hydrogen's the only one that has its full shell of 2. It's, again, sort of an exception to what the general rule is. So with oxygen, what we have so far are 6 electrons, but we want 2 more. And for nitrogen, we start with 5, but we want 3 more. Now, the way that we get these electrons in pretty much all of these organic interactions, the way that we gain and lose them when we're forming our molecules to begin with, is we form covalent bonds. So with the oxygen, what we want to do is form 2 covalent bonds. So 2 covalent bonds, and that will make 8 electrons in the outer shell. And I'll give you an example in a minute. And then so for nitrogen, because we want 3 extra electrons, we're going to have to form 3 covalent bonds. And again, that will give us 8 electrons in the outer shell. So again, you might want to add that to the notes that you already have, etc., etc. Maybe this might be something that gets put into your cheat sheet, anything like that. So just more of a visual representation. If I have, say, a carbon here and it's bonded to some hydrogen, and I have an oxygen sitting around. Now, the carbon at the moment, it's got 1, 2, 3 bonds. it's not happy either at this point, but there's one extra electron sitting around that it can covalently bond with. Our oxygen as well, we said, has 6 electrons. Kind of mucked up my drawing, but that's okay. We have 6 electrons. These guys can bond covalently. At this point, the carbon has 2, 4, 6, and now 8 electrons. It's happy. It won't participate in any more bonding. The oxygen has 1, 2, 3, 4, 5, 6 that it started with, plus a 7th that has come from the carbon. So the oxygen at this point is not happy. It still needs to make that second covalent bond. So the way that we might go about that is by forming another bond with something else. Maybe we might form a bond with a hydrogen. So our hydrogen over here offers up 1 electron. It wants to form 1 bond to get a full outer shell, and it can do that here. So the hydrogen now collectively has 2 electrons in its outer shell. It's happy. The oxygen has 1, 2, 3, 4, 5, and 6. Like we said before, is what it starts with in its outer shell. A 7th from the carbon and an 8th from the hydrogen. So it's now happy as well. With those 2 covalent bonds, it now has 8 electrons in its outer shell. This is actually an alcohol. So you may have seen that already when you were doing your first table with all of your functional groups. That OH here is an alcohol functional group. And this is sort of how it ends up bonding with a carbon or a chain of carbons, possibly. Obviously, this chain only has 1 in there, but possibly a chain of carbons. This is sort of what it looks like using our Lewis dot structures. Looking underneath, I'm going to start with another CH3 group. They're quite helpful to work with at the beginning. And again, we have 1 free electron that we might be able to form a bond with. But rather than forming a bond with oxygen, we're going to be forming a bond with nitrogen. Sorry, excuse that extra red mark there. I don't know what I was doing. But anyway, we have our nitrogen. This nitrogen has 5 electrons on its outer shell, according to the periodic table as we set up here. It wants to form 3 covalent bonds because we need 3 extra electrons to get to our outer shell of 8. So first off, I'm going to add on this carbon. It is sharing its electrons. The carbon's now happy. It has 2, 4, 6, now 8 outer shell electrons. The nitrogen has 1, 2, 3, 4, 5 to start off with, and a 6th from the carbon. What we then might be able to do is add on some hydrogen to the other bonds, or to the other electrons to form bonds, I should say. Again, the hydrogens now have 2 electrons. They're happy. The nitrogen has 5 on its outer shell that it starts with, plus a 6th, a 7th, and an 8th electron from all of the atoms that it's bonding with, making 8. Again, the nitrogen's happy, and it's sitting in a spot where everything is electronically stable. There are other ways to draw up chemicals with our oxygens and nitrogens. Again, as long as it's got those 2 covalent bonds or 3 covalent bonds respectively, you can sort of make anything you want. So some other examples of things that you might see or encounter as we work through this unit is maybe rather than there being bonds with maybe 1 carbon and then the rest of them being hydrogen, there might be some other stuff going on as well. So here, for example, I have an organic compound where both of the bonds here at the oxygen are with carbons. This is a possible chemical that you may see. Another example might be something like this, where... Oh, give me a sec, I made a mistake. Excuse me. We have, maybe say 2 carbons, CH3 here, CH2 here. At the moment, this carbon needs 1 extra bond. Oh, I've made a big mistake. Excuse me, that's not the example I had in my head. Scratch that. Apologies. Maybe I have something like this where I have a carbon and a double bond onto the oxygen. So we looked at double bonds before, and we said that what this means is the oxygen is sharing 2 of its electrons with the carbon, and the carbon is sharing 2 of its electrons with the oxygen. Both bonds together mean that the oxygen is gaining 2 extra electrons. In other words, these 2 covalent bonds giving us our 7th and 8th electron in the outer shell. If I was to fill that out, maybe it might look something like this. Apologies for that first one. This is a better representation. Anyway, with our nitrogen, we can get a sort of similar story going on as well. Maybe the nitrogen might be in between parts of the carbon chain. This is, again, something that you may see. So we might end up with something like this, where the nitrogen, again, has 3 bonds all the way around. So it's got its 5 electrons that it's starting off with, but then an electron from every single bond, meaning that it has an outer shell of 8, but doesn't necessarily have to be bonded to only 1 carbon and then the rest hydrogens. So I'm just showing you a couple of examples of what that may look like, but I'll leave that there for now, and we'll get into some more stuff around functional groups and what they look like, and then we'll do a couple of naming activities afterwards. Thanks.